Hello, you are able to hear me, right? Let us start. Okay, go to the class and start it. Okay. So yesterday we gave the brief overview of that what kind of clock relations are possible, right? So we have six clocks uh, relations possible, right? Which can be the problem and creating the metastability. So we went inside the FIFO, right, and start discussing the FIFO, right? Now the question comes, okay. So let us say that this is a TX and this is a FIFO, right? Now data was sent here. I was saying that FIFO is telling that I am ready. He is telling that this data is valid or not, right? Ready was not of FIFO empty, right? Correct. And there was a common clock if it is a synchronous FIFO, right? So in any case, if we see that the timing is not meeting between these two in any of the path, right? This question can be a normal question, right? Anyone will put a timing here and say that timing is not meeting. So let us see in the timing diagrams. So if we see that this path was critical path and we were not able to met the timing, right? So when we are not able to meet the timing, we have to put a flip-flop here, right? So that we can say that if the delay was 8 ns between them, so we can say that 4 ns is this side and 4 ns is this side, right? We put a flip-flop here. We have not put in the valid because my timing was meeting properly. The delay was 4 ns only. But in this part, delay was 8 ns. We put a flip-flop, right? So let us see all the possible scenarios. For example, there was a data D1, data D2, data D3, data D4, and D5. And for example, D1 was an invalid data, D2 was a valid data, D3 was valid data, right? And D4, D5 was invalid data. So means that FIFO will only sample the data D2 and D3. Make sense? You are people getting right what I'm trying to say. Right now, right now, for example, we have put a flip-flop here, right? So this D1s will be shifted. So it will be shifted by one clock due to the flip-flop D1, D2, D3, D4, D5. Now you see, if we are not putting the delay line in valid, earlier valid was supposed to be D2 and D3, but due to this delay, you see that D1 is D2 are valid data, not D3. D3 became invalid and D1, D2 are valid data now. Make sense? Now D1, D2 are valid data, D3 is invalid, but originally transmitter sent D2 and D3 as a valid data, right? So now this means that we have to delay this also. So we have to put one more flip-flop here, even though timing is meeting. Two here, to any combination. You can put zero delay here and four also because timing is not the issue. Our latency is creating the problem. Cycle shift is the problem. So you see that data is being shifted. So we have to shift the mm, this also valid also. So we when we shift by one cycle, you see that it is shifted and come like this by one cycle due to this. So if you see that now really data D2 and DD3 is only sampled, right? So you are putting this, right? But still FIFO is working fine. That is, there is no issue on FIFO working, right? So we have to see how FIFO will start. FIFO is still working good, but in one condition, FIFO will stop working, right? So now are you able to map why if the D1 was shifted due to the this flip-flop timing meeting, right? ST, if you are not clear, we can teach. But you just understand one thing. If timing is not meeting, we are just putting a flip-flop. Why? We can discuss. If we are meeting, if we are putting 4NS this side, 4NS this side, so timing is meeting. D1, D2 got shifted by one cycle like this. But we have not put in flip-flop here, right? So what we did, we saw that D1, D2 becomes valid instead of D3 and D2. So it went bad. So we put a uh, flip-flop here also, right? Till this point is clear or not? Till we go to the critical point of when FIFO will fail. Clear or not? Everyone have to tell. Till this thing, everyone is understanding, right? Right. Okay. Let me put my camera off. Okay. Now let us go to the next problem where let us see use this. Now use that this is TX, this is FIFO. We have put, I don't know why. This is not a demo class. People are requesting to join, but they're not ready to pay. Yesterday they joined the demo class, day before yesterday, now today they want demo again. Okay, so this is we put the data here, we put valid here. Now you analyze one thing on the waves. Okay, for example, this is ready signal that FIFO is not full, and depth of FIFO is just 4 cycles. Okay, so what will happen? Real data come deep, and let us assume that all the data are valid to increase the complexity so that we can understand the things, right? Okay, so what will happen? Okay, so what will happen? That this one is a original data D1, this is second data D2, this is D3, and this is D4, right? Now this will be shifted due to the shift. It will become D1, it will become D2, it will become D3, right? And so on, the data is going on D4, 5, D4, D6, and D5. Now this is the case. And the valid is all every time valid. So let us leave the valids. Now, if you see data is reaching here by one cycle delay. So let us say that here write happens in the one cycle to write. So memory return is D1 data is written, D2 data is written, D3 data is written, D4 data is written, means all 4 locations are filled. And the same time, as soon as these 4 location happens, I raise a FIFO full condition, right? Now, if you see, as soon as the FIFO is full, right, TX has to stop sending the data. TX has to stop sending the data means if you see that D1, D2, D3, D4, D5, D6, yes. As soon as we send a FIFO full, right, here, it will not update, it will be a D5 because FIFO full is sent, right? But you see that how many data are launched before this because this is the ready in the time of FIFO full. So FIFO pool will, like you can say, FIFO ready will go down like this, right? You can take FIFO pool high or however. So ready will go down, right? And D5, D6 will not come, but D5 will come. Now you see D1, D2, D3, D4. D4 data are written in the memory. P4 is full, but still D5 is launched. This is launched, which FIFO cannot use. Extra data is launched. Why? Because this is sending data first. Once after one cycle, it is writing. So by the time it informs it that I am full, it has already launched the data because there is a in the loop. This is a faster edge. There is not an exact edge. So what it means, like if there was no this thing, this was not nothing. It was just simply writing data like there. So this might must have happened here one cycle before, right? And if this happened here means the D instead of D5 update, D4 will only come. So signal will go like D4 constant. D5 will not come. Till FIFO is again spaces are available, right? So means D5 is a lost data. Throughput is one place, uh, latency is one place. Here the data is itself lost. Means due to this timing meeting, to meet the timing, we put the extra flip flops. If architect has no don't have understanding at this level, he will say that just put this and that it will start working. But he will, if he will not make this diagram and understand it, then he will found that the chip will fail. After every four data, one data will be lost. So it is a very big fail of a design. Means 25% or like 1.5, 20% data is lost due to this time meeting solutions. I will give you the solution, but at least everyone should appreciate that problem is there. Is any everyone appreciating this problem? Abhishek Verma?